Hello guys, welcome back to Tronic Synergy. So last time we did a password lock system which had 6 push buttons and only 4 push buttons were used to put the right password. Right here we have the 4 NE555s which were still in the previous circuit connected in bistable mode, which were used and which are still used to store the bits that you put in your password. So the circuit that you're seeing right now is a bit different from that one that we did yesterday, because right now we have a 74LS195 programmable password lock. So let me just break it down for you to understand. So right here we have the input panel. This is where you put your password. It's a 4-digit password, but some of them could be on, some of them could be off. And having said this means that we have because we have 4 push buttons, there can be only 16 possible combinations which you can put here in order to get the correct password. Yeah, so right down here below we have this reset back push button, which resets everything that you have in your NE555s or what is stored or what you had put before, if you want to correct what you did. Right here next we have enter. So once you press your or once you input your password, you press enter and the system decides if your password is correct. Right here next we have the NE555s, which are connected in bistable mode, and as I've said before, they are used to store the bits that you are inputting in your password. So if I press 1, so this first NE555 stores what I've pressed here, and the only way to remove that is just to press the reset, which clears what I have on any NE555. Right here on top you can see something blinking right here, meaning that it's a clock. So because we said it has a 74LS195, meaning that it stores. So here we have a 4 switch deep switch, which is inputting data into this 74LS195 shift register, and once the clock is high, that input is transformed into, or it's converted into output. So what we have in the input is what's taken or what is stored in those flip-flops seen in the output. So this right here on top of the output of this 74LS195. So the purpose of this part of the circuit is just to store the new password. So this is what I used to program. I am using to program the circuit to the new password. So right now you can see it's 000. So the password is set to 000. So if I just put 000 to my circuit, then the password is correct when I press the enter. You can see the password is correct because that's what I have in my program. So I've set my program to password to 000. So because my inputs are all 000, the password is correct. And how does it compare? How does it compare this programmed one and what you're putting as the user? So that comes to this part of the circuit. We have an OR right here, XOR gate. So the purpose of XOR gate, if you can remember, the truth table, or how an XOR gate or XNOR gate, how an XNOR gate operates is that when the inputs are alike, if A and B, A is equals to B, then the output is a 1. Yeah, it's a 1. Then the output is a 1. So if A and B is 0, then the output will be 1. If A and B are 1, then the output will be 1. So meaning that if we compare what you are putting as the first bit, if they are common, or if they are equal to the first output of the NE55, then it's going to give a 1, meaning that it's true. You have set the correct thing. Then all those four inputs are taken into the XOR gates, which are 4 in number, and they compare all bits one by one. Compare all bits. So this first one to this first one, this second one to this second NE55, the third one, then the fourth one. Then all those outputs are taken to an AND gate, which then tells the circuit that all your inputs are correct. And when I press the enter key, it's a 5-input AND gate. When I press the enter key, and because all the other conditions have been met, it turns on the circuit, meaning that your password is correct. if let's say I program my circuit like that, I've now pressed 1, so now the password is 1000. So right now the initial password was 000, but right now we have set the password, new password, to 1000. If I press enter, it's not going to work because my password right here I've pressed is 000. So if I just press 1, that's now that now aligns itself with this one. So if I press enter, it's correct. The circuit says that your password is correct according to what is programmed before. If I add another let's say like that, now as you can see we have 1010, so we have set our password to 1010. So if I now try this right now, if I press enter, it's not correct because we have updated our circuit to the new password 1010. So I just have to put 1, so it's already on, then 0, then 1, then 0. So this now correct password. If I press enter, it turns on. So that's how the circuit compares what you have put and what is programmed before in order to give an output. If I just show you the schematic, it's pretty exactly the same that of how I've explained. Right here we have the button interface where you put your password, the N55s which store the bits that you have put in your push buttons. Right then down below here we can start here, the 4 switch deep switch which programs the register. Now this is a register, so once I enter, or once I set my new password, it's stored in this register. Once it's stored, now these XOR gates are going to compare the outputs from the N55 to the output of the 74LS195, which is the set, or which is a programmed password. So once it compares the two of them, you can see there are 4 of them, so it compares every single bit from the most significant to the least significant. So it checks all of them from here to here to here to here. So all of these bits have their own XOR gate to compare with the 74LS195, and if the password is correct, if it compares and it gets that they are equal, then it means that it's true. So this is going to give a 1, a 1, a 1, a 1 output. This 1 output enter an AND gate, and since it's a 5 input AND gate, the last input is the enter key. So if I press enter and all these inputs are on, then the AND gate will give a 1 output. Once it gives a 1 output, it's going to turn on the LED, the buzzer, meaning that access has been granted to you. And if any of the bit is wrong, if let's say you have put a 0 and the register is 1, then it's not going to turn on totally because there's a mismatch in what you're giving compared to what is programmed before. So this is basically how the circuit operates, and how the circuit is programmable. So as you can see, very simple circuit, and I hope you can try this at home. Very easy circuit, and yeah. So thank you very much guys for watching. Please subscribe to Tronics Energy, and hope to see you next time. Goodbye.
You saved me. Yeah, this lost cause might be cute.